Here we have the cooking oil, which is just free from local restaurants. You can tell how good the oil will be based on the color. Usually the darker color is better.
There's a lighter color there. The dark oil is back there. The unprocessed cooking oil, or not cooking oil, but just oil from the restaurants is filtered through here. There's some holes. You got a lot of residue on the sides to get a clean product that can be used.
Here we have barrels of methanol that are used to mix with the oil that's filtered, and we'll talk about that a little bit later.
So the strained oil comes to this holding vessel here, and then it's pumped into this. About 40 gallons are pumped into here, and it's heated up to between 120 and 140 degrees. Around 130 is optimal because methanol will vaporize at 140 degrees.
Is that Fahrenheit or Celsius?
That's Fahrenheit.
Right over here we have the tank for methanol that we saw a little bit earlier. This is where the methanol goes and is pumped together with the oil here. We turn the heat off whenever it starts pumping because it's an exothermic reaction, so we don't want too much heat released there.
About 8 gallons of methanol are used for every 40 gallons of oil. And there's an acid catalyst. There's a potassium hydroxide is used as an acid catalyst in the reaction, and there's a system of.
Yeah.
You want to talk about that
So
first?
one gram of potassium hydroxide is put into distilled water, and then this is extracted along with the alcohol, and then we use the indicator phenolphthalein to determine when it will be how much potassium hydroxide we need. So you add a few drops of this, and then when it turns pink, you know how many grams you'll need of potassium hydroxide, which is in this bag.
So once you know how many grams of potassium hydroxide you're going to need, you measure out the flakes, and then you take those flakes and those go into the methanol holding container, and you mix that up until all the flakes are dissolved so that you have a mixture of methanol and potassium hydroxide.
It's about 2,000 grams of KOH per 8 gallons of methanol. Usually that's what it works out to, but you can really tell that from the titration test. It's where you tell the exact amount.
Now overall, at the end of the cycle, we've said this a few times, but you're going to use about 40 gallons of the oil, the recycled oil, about 8 gallons of the methanol potassium hydroxide mixture, and your yield is going to be anywhere from 35 to 37-ish gallons of usable biodiesel.
And when you react them, it's filtered to that vessel over there, where the glycerin is drained off the bottom.
This vessel, after you react it, you leave it set for about a day so that all of the waste products that aren't usable in the final product settle to the bottom. Do you want to talk about glycerin?
Yeah, and then the glycerin is drained, and the glycerin that can be the waste product can be used as fertilizer.
And then you have your usable biodiesel.
You can, after you get that too, you can filter it too to make it even more pure. There's a system of filters over here and then over here as well that use pure light filters to get any impurities out of the biodiesel, and then you have a usable product.
Okay, so here we have an example of the glycerin that settles out from the biodiesel, and this has to be filtered off before you can use it. And then this is an example. It's kind of cold, so it's kind of freezing on the outside, but this is usable biodiesel that you could just put in your truck or machinery.
Supposedly,
Look at that.
supposedly it's a really good lubricant for your engine.
Yeah.
As far as engine wear goes. Let me see, I can get a little bit more.
And just,
All right.
you can talk about how it doesn't burn.
Yeah, liquid biodiesel doesn't burn on the table, but as you can see, the flames were very flammable. I mean, the vapor was very flammable. Exploded.
Can you do it again?
Yeah?
Yep.
Oh, that's awesome.
mark for gallons.
Right.
And